and welcome to another Walking Talking Mock. This is Further Maths, Paper 1, and this is 2012. So I know your exam is tomorrow and this is a bit late to be doing this, but why not? Hang on, I don't even have a pen. What colour should I use? Let's stick with the purple. Okay. So we start off with the functions question. So f of x is 2x squared plus 7 for all values of x. What is the value of f of minus 1? Okay, so they don't give you much space to work out, do they? Put minus 1 in there. Minus 1 squared is 1, times by 2 is 2, plus 7 is 9. What is the range of f of x? So remember, the range means what are the possible values of y, or, of the output. A nice easy way to work this out is to sketch a graph, if you like sketching graphs, or just think to yourself, well, if I put in this value of x, what am I going to get? And if I put in that value of x, what am I going to get? So if I put in 0, I'm going to get 7. I'm just going to jot that down. If I put in a big positive number, it's going to get bigger. If I put in, a gazillion, I'm going to get 2 gazillion squared plus 7, which is a very big number. So I can basically get infinity, positive infinity. Now I've got to think, can I get anything smaller than 7? Well, if I put in negative 1, I'm going to get 9, because the negative squared makes a positive. So actually I can't get anything smaller than 7. So 7 is the smallest possible answer of f of x, and the biggest is infinity. I mean, you can say it's between 7 and infinity, but actually you don't need to say it's less than infinity, because every single thing in the world is less than infinity. So you can just write f of x is bigger than 7. Okay, now we've got a matrix. Work out the matrix AB, so we're going to times these together. I don't know if I've emphasised this before, but the order that you times matrices is important. I can't put the B in front here, because that would be BA. And BA is not the same as AB with matrices. It is with numbers, 2 times 4 is the same as 4 times 2. With matrices, the order that you times them in does matter. It makes a big difference to the answer. Oh, come on, pen, don't fail me now. We're so close to the end of exam season. Let's use black. Okay, so we do 2 times 5 is 10. 0 times 4 is 0. That's my top row. 1 times 5 is 5. 3 times 4 is 12. That's my bottom row. So that's 10, and that's 17. Sorry, that was a sneeze in case you couldn't tell. By the way, you might be thinking, that's not a matrix, that's a vector. A vector is a matrix. A matrix is not a vector, but a vector is a matrix. Make sense? Yeah. I love how short these questions are, don't you? Okay, number 3. Work out the greatest integer value of x that satisfies that inequality. Okay, so we can just solve this. I'm going to use this space down here to work it out, because I don't want to work it out on lined space. Take away 10 from both sides, divide by 3. Okay, the greatest integer value. So, whole number that's... Okay, we're not allowed minus 3, because it has to be less than minus 3, not less than or equal to. So what's the next integer that's less than minus 3? That's minus 4. Okay. Factorise fully. Okay, I'm not going to use that method that some people prefer. I'm going to use my method, so things that times together to make 40, could be 8 and 5, could be 4 and 10, could be 2 and 20, and once I've times one of them by 2, it's got to add together to make minus 2. Okay, so let's think. I'm going to put 4 here and 10 here, and that's going to make 10x, that's going to make 8x. If I have minus 10 plus 8, that's going to make minus 2. So it's going to be that. Oh, now that's technically not factorised fully because 2 is a common factor here and here. So actually, instead of 2x minus 10, I'll put the 2 on the outside and make that x minus 5. I mean, actually what I probably should have done to start with is start by taking 2 out as a common factor, just because that's going to make it easier to factorise anyway. But either way. Okay, now factorise fully this. Right, what you are absolutely not going to do in this situation is expand it out, because it says factorise, which is the opposite of expanding out. What is the common factor here? Can you see a common factor? I can see a common factor. It's the x plus y. That is common. So x plus y is going to go on the outside. Okay, if I divide this thing by x plus y, what have I got left? X plus y. If I divide this thing by x plus y, what have I got left? 2x plus 5y. Now let's just simplify that. That's 3x and that's 6y. Ooh, there's a common factor there still, which is 3. So I'll put the 3 on the outside and I'll make that x plus 2y. So there we go. Simplify this. Okay. Hang on. Let's try and get some more sunlight in here. For some reason it's just coming out really dark. I don't know why. Let me just turn my light on. Did that make any difference? I don't think so. Okay, so we're going to cube everything. So we're going to cube the 2, we're going to cube the c, and we're going to cube the d to the power of 4, which would make that. These questions are so short. It's lovely. I mean, it is going to mean that there's lots of questions. Like, well, how many questions in this paper? 16, and it's only it's an hour and a half. Oh, so same. It's actually got like fewer questions than the Maths GCSE, but they're shorter. Okay, solve these simultaneous equations. Do not, shubham, use trial and improvement. So, I don't like the way these are written. It's kind of ugly. I think I'm gonna make them like something x plus something y equals something, because then I can use the elimination method, and I'm in the mood for that for some reason. So I'm going to make it 3x minus 2y equals minus 4. And I'm going to make that 2x minus 3y equals, no, 2x plus 3y. Yes. Equals minus 7. And I will let's times this one, let's number them. I'm going to times the first one by 3, and I'm going to times the second one by 2. So 9x minus 6y equals minus 12, and 4x plus 6y equals minus 14. I'm going to add those together so that the 6y and the minus 6y cancel out. Minus 26. Okay, that's good news because I can do that division. That's just going to be minus 2. Then I'll substitute that into, let's put it in this top one, in that form. 2y equals 3 times minus 2 plus 4. So 2y will equal minus 6 plus 4, which is minus 2. So 1y will equal minus 1. And then I'll just check that in the other equation. So 2 times minus 2 equals minus 3 times minus 1 plus, nope, minus 7, question mark. Minus 4 equals 3, take away 7, Yes, it does. So that's correct. There we go. Circle theorem, yay! The diagram shows a cyclic quadrilateral. A, B, C, D. ADE is a straight line. CE is a tangent to the circle. Ooh, I see a tangent and I see a triangle. So what am I going to be using? Alternate segment theorem. So I know that that angle there is the same as 46. And I know that that angle there is the same as, okay, that angle, but I don't know what that angle is, so who cares? Okay, what else do I know? There's no radius, so there's no radius meets tangent thingy. Right, cyclic quadrilateral, so if that makes 70, 83, then that's gonna be 97, the whole thing of that angle. And oh, we can use a different alternate segment, can't we? Because there's two triangles here, so we can do in that triangle. Oh, so that's going to be 46 as well. Either because of the alternate segment theorem, or because these are angles in the same segment. And actually that's going to be 37 there. Angles in the same segment. And what am I even trying to find? X, okay. Right, if that's 97, then that is going to be 103. And then, oh, so I didn't need, I had enough information already. 103 plus 46 is 149. So that is 180 minus 149, so that is 31. Okay, so now, oh, yay, we don't have to give reasons. Oh my gosh. I love further math so much. You can just work out the answer. Let me go through it for you though, because I realised that I was kind of just acting like I was talking to myself. So I started by saying, actually I can't remember what order I did things in, but that angle has to be the same as that angle because of alternate segment theorem. And then, you know what, let's rub out the things I didn't end up using. So I never used the 37, and I never used that 46. Okay, from there I then said it's a cyclic quadrilateral, so these two and these two here have to add up to 180. So 180 take away that is that, and then this is a straight line, so 180 take away that is that, and then this is a triangle, so they add up to 180, so it's that. Okay. A curve has an equation, ooh, it's a cubic. When x is minus 1, show that the value of dy by dx is minus 7. Okay, let's find dy by dx. So that's 3x squared plus 10x. So if I put in minus 1, what's that? Minus 1 squared is 1, times 3 is 3, times 10 is minus 7. Okay, shown. And then work out the equation of the tangent at the point where x is minus 1. Okay, so we know that the gradient is minus 7, so we know it's y equals minus 7x plus c, because we're going for the tangent here, so the gradient is exactly the same. If we were going for the normal, I would be doing 1 over 7 instead. Okay, at the point where x is, I need a y value as well, so let's do that over here. When x is minus 1, what is y? What's the equation? X cubed plus 5x squared plus 1. Okay, so y is minus 1 cubed plus 5 times minus 1 squared plus 1, minus 1 plus 5 plus 1, which is 5. Okay, so minus 1, 5 is a point on the line. The reason why I had to do that is because to find the y-intercept I need to put in a point that I know lies on the line. And they didn't give me one, they only told me the x-coordinate. So I had to find the y-coordinate by using that. Okay, so 5 equals minus 7 times minus 1 plus c. So 5 equals 7 plus c, so c is minus 2. So y is minus 7, x minus 2. Okay, that's going to be the end of part 1. I'll see you in a very short time for part 2. Bye!